Okay, this next section is about gas forming reactions, and the goal is to identify common reactions in which a gas is formed and write equations for these reactions. So, there are 4 different kinds of gas forming reactions, and this is one kind, a metal carbonate with an acid to make a salt, carbon dioxide, and water. So this is an example of a metal carbonate, sodium carbonate. Reacting with acid, the salt it makes in this case is table salt, sodium chloride, and you make CO2 and H2O. Now, a similar reaction is a metal hydrogen carbonate or a bicarbonate, plus acid to make salt, carbon dioxide, and water. So this is sodium bicarbonate, also known as sodium hydrogen carbonate, a metal hydrogen carbonate, reacting with acid to make, in this case, also table salt, carbon dioxide, and water. So you'll notice that these products are almost identical except for the numbers of the salt and the numbers of the acids that react with the carbonate. So what is the key to balancing one of these reactions? And the answer is this, that for every carbonate, you need 2 hydrogens and you make carbonic acid, and that decomposes into CO2 and H2O. That's the key to this reaction. So imagine you get the hydrogen carbonate ion instead of the carbonate ion. You still need 2 hydrogens with this guy, but it already comes preloaded with 1. So how many hydrogens do you need? Just 1. And you'll make carbonic acid, which decomposes into CO2 and H2O. So the key is making H2CO3 for these reactions. The other 3 reactions are a metal sulfide plus acid to make salt and dihydrogen monosulfide. So here's a metal sulfide, magnesium sulfide, reacting with acid, hydrochloric acid. The salt that this makes is magnesium chloride plus dihydrogen sulfide. And you can see how this gets balanced, right? If we're gonna not see that 2 there, you gotta say, well, 1 magnesium, that's good. 1 sulfur, that's good. 1 hydrogen, 2 hydrogens, so you put a 2 there. And so forth and so on. The next is a metal sulfite, not sulfide, sulfite, with an acid to make salt and sulfur dioxide and water. Now, a sulfite is like a sulfate, same charge, but a different number of oxygens. So instead of SO4, it's SO3. Ite always has 1 less oxygen than the 8. So we have potassium sulfite plus hydrochloric acid makes potassium chloride plus sulfur dioxide plus H2O. And then there's the ammonium sulfite, or ammonium salt, which reacts with the base. And ammonium salt is simply an ionic compound with ammonium as the cation, as we see here. So this is a weird ionic compound in that it's not a metal and a nonmetal. It's nonmetal and nonmetal. Now, how do we recognize this as an ion? It starts with NH4, which we have memorized as a polyatomic ion. So an ammonium salt plus a base turns into a salt, ammonia, and water. So here is a problem that we have. Gas forming reactions. Write a balanced equation for the reaction that occurs when nickel 2 carbonate is treated with sulfuric acid. So for nickel 2 carbonate, we have to know that nickel 2 is 2 plus, carbonate is 2 minus, and therefore nickel 2 carbonate, if we do the switch and simplify, is this. Or we could just recognize they both have the same charge, so it's 1 of each. So nickel 2 carbonate, solid, reacts with sulfuric acid, aqueous, and we have to figure out what is going to happen here. Now, how do I know this is a solid? Carbonates are not soluble. Now, this is one of those carbonate reactions where we need to make carbonic acid. That's the key. So there's the CO3, there's the CO3, there's 2 hydrogens, there's 2 hydrogens. This is balanced. Now, we don't write H2CO3 here. what do we write? We write H2O and CO2. Now, what's left over? One nickel ion and one sulfate ion. And since sulfates are soluble, this is aqueous. And this is your balanced reaction. Now, in the previous examples, we put the metal salt first, and then H2O and CO2. Does the order matter? Absolutely not. Okay. Let's take a look at some more examples here. We have two more. Write an overall balanced equation for the reaction of ammonium sulfide with HBr. So here's ammonium sulfide. Now this is going to be aqueous because of the ammonium ion plus HBr. Okay, so this is the one where ammonium salts. Well, actually, we've got to think about this. Is this the one where the ammonium salt reacts with the base, or is this the one where a sulfide reacts with the acid? And the answer is, well, there's no base here, so it's got to be the one where the sulfide reacts with the acid. So the sulfide reacts with the acid, and we know that one thing for sure is we're going to get this dihydrogen monosulfide. There's one sulfur here, one hydrogen here, so I'll definitely need two of those. And then what is the other thing that forms? A salt. So what are we left over with? Two ammonium ions. Whoops. Plus one. And two bromide ions. So we don't want to write this because it can be simplified. What can that be simplified to? This. But how do we write down that we have two ammoniums and two bromides? We put a 2 there. And so now that's balanced. And here's the last example for this section. Siderite is a mineral consisting largely of iron 2 carbonate. Write an overall balanced reaction. Name the products. Oh, and that reminds me, I don't think I finished part of the previous problem here, which is name the reactants in the products. So this is called ammonium sulfide, hydrobromic acid, ammonium bromide, and dihydrogen monosulfide. Okay, so now we can look at this one again and we can work on it. So iron 2 carbonate, I'm going to put the formula for iron 2 up here, the formula for carbonate up here. And since they both have a charge of 2, I want one of each. It's a solid because of the carbonate. It's going to react with nitric acid. Now, we have one carbonate and we need 2 hydrogens. I only see one here, so I'm going to put 2. So those 2 hydrogens in that carbonate will make H2CO3, which make H2O plus CO2. And then we have to look at what's left over. We have the iron 2 ion, and we have 2 nitrates. And this is, of course, is aqueous because of the nitrate. All right, thank you for listening.